All right, Algebra, this is lesson 5.1, solving systems of linear equations. When you hear the phrase systems of linear equations, what does it make you think? Yeah.
I still have two or more linear equations.
Yes. So when it says system, all you need to think on that is that there's going to be two or more linear equations that you have to find a solution that is correct for all three. So one answer for all three. Does that make sense? Okay, what is the definition of a solution of a system of linear equations, Chloe?
In two variables is an ordered pair that is the solution of each equation in the system.
Right, so you'll have an x and a y that solves all of the lines in that system. So if I have three linear equations, whatever x, y value I have, whether it's 2, 1, whatever it is, it will solve all three equations, okay? So there's multiple ways to solve systems of linear equations. I think we show you all of them. I'm not sure if it's in this lesson or just in this chapter. So let's look at how to do the first one. It must be locked. All right. So you're going to write this in your journals. You're going to tell whether the ordered pair is a solution of the system of linear equations. So for A, we have the ordered pair 2, 5, and then we have our two equations, x plus y equals 7, and 2x minus 3y equals negative 11. If you didn't know how to do this, what would be an easy way to quickly decide if those were solutions? Yeah, just plug them in, right?
Yeah.
So if I plugged in 2 plus 5 for the first equation, does 2 plus 5 equal 7?
Yeah.
So then it is a solution for that equation. So now let's do the second equation. Plug it in. 2 times 2 is
4.
And 3 times 5 is?
15.
So 4 minus 15 is negative 11. Yeah. So then it is also a solution for the second equation. So the original question is, tell whether the ordered pair is a solution. You would say yes. The ordered pair is a solution to this system of equations. On your paper, you can just show me the work that you did to substitute and then say yes. You don't have to write that whole sentence.
Okay.
Need to pause for a second. All right, so now we're going to do B. So in this one, we have our ordered pair is negative 2, 0. Our first equation, y equals negative 2x minus 4. We're going to plug in. Where do we plug in the negative 2?
On the x.
On the x. And what do we plug in for y?
0.
Very good.
0.
So then we're going to multiply here. Negative 2 times negative 2 would be?
4.
Positive 4. So then you have 4 minus 4, which equals? 0. So then is that a solution to this linear equation? Yes. All right. Our second equation is y equals x plus 4. Plug in your values. So we have 0 equals negative 2 plus 4. What is negative 2 plus 4? Positive 2.
Yeah.
Does 0 equal 2? No. So it is not a solution for this equation.
Yeah.
So then the original question is saying, or the statement is asking whether the ordered pair is a solution. So is the ordered pair a solution to this system? It is not. So you would say not a solution. Or no solution. That's fine.
Yeah.
Good?
Yes.
Not too terrible, right? All right, let's do the next one.
Down 2.
Yep. Real quick. So this is the basic 3 steps you would do when graphing. Yes, there will be graphing in this one. Not my favorite. So once you've learned it, you may choose an alternative method. But you have to learn it first. So the first step when graphing is you graph each equation in the same plane. So you're going to graph each line. And then you estimate where the two lines cross. And then that's the coordinate that would be your answer to the system. So I'm going to show you now. I explain it and then I show it because visual's way better. All right. So solve the system of linear equations by graphing. This is where it's important for you to read the instructions because you do have to graph for your answer on this one. If you are not graphing, I will not give you the full points. So in order to graph a linear equation, what form would we want the equation to be in? Perfect. Y equals mx plus b because that's the fastest way to graph. Are these two equations in slope-intercept form?
Yes.
Hallelujah. So we can just graph them. So you'll put a coordinate plane. The first one, what is my y-intercept? 5. So we go to 5 when we put a dot. And then what is my slope?
2.
Negative 2. So I go down 2 over 1, put another dot. And then you see that they've connected the dots and made their line. Yes, you do need to do this in your journal. Yep, I will pause. It doesn't have to be crazy pretty. Just slap it in there. At the y-intercept, which is 5. So you go up to 5 and put a dot. And your slope is down 2 over 1. So second dot would be there, and then you connect them. Draw a line. Okay, in our second equation, where's our y-intercept? Negative 1, so I put a dot down here. And what's my slope? Positive 4. So I go up 4 over 1, put another dot. And you can see where these two lines cross, right? So where the two lines cross, that is considered the solution to this system. It's the answer that can be on both lines. So now we just look at our graph, and what's our x value for where they cross? 1. And what's our y value?
3.
So our solution would be 1, 3. If you want to check it, like if you're a little unsure, you can plug those into the equation and see if it works. But if your graph is drawn well, you'll be fine. I never liked the fact you had to check it because I was like, I would rather just do the algebra than graph it and know for sure. But we're going to practice graphing. That's why I bought you graph paper, because when you graph on graph paper, the squares are perfect and your lines will be nice. Say that again. I don't know. I haven't looked at it yet, to be honest. We'll find out. All right, any questions on how to graph to solve for a system? Go ahead, Elian. No questions? Just a little. We'll practice, don't worry. All right, and our last example. Short lesson. I like this. All right, here's a real life problem. So those of you who are going to go into roofing. A roofing contractor buys 30 bundles of shingles and 4 rolls of roofing paper for $1,040. In the second purchase, same prices, the contractor buys 8 bundles of shingles for $256. Find the price per bundle of shingles and the price per roll of roofing paper. So we need to create 2 equations. Okay? So let's verbally talk through this. You know the total price for the purchase, right? What was the total price for the first purchase? $1,040. What was the total price for the second purchase? All right, good. And then how much were the cost of each item? We can assign them as X and Y, right? The shingles and the rolls of roofing paper. Do we know the quantities we bought for each item? 30 and 4, and then 8 for the shingles. All right. So this will help us create our equation. So we know our total was 1040. In that purchase, we bought 30 bundles of shingles and 4 rolls of roofing. So you can see here they have, well, here's the second equation. So this one will be 30x plus 4y equals 1040. This second equation, we bought 8 bundles. We did not buy any rolls, right?
Yeah.
So 0 rolls. And that price equaled $256.
So there would be a y now, right?
Correct.
So 8x equals 256.
Correct. So look at the very bottom of the screen. You can see how we created our 2 linear equations.
Yes, ma'am.
All right. So now that we have 2 linear equations, can we solve for the variables?
Yes.
Yeah. I believe they're going to have you do it by graphing this time. I would rather do it algebraically. But we're going to graph. Bless you. All right, so are these in slope-intercept form?
Yes.
No,
No. The first one's not.
they're not. So, oh, they didn't do it on here. All right, I can do it on the TV for you. Woo. All right, so we have 30x plus 4y equals 10, 40. Let's put this in slope-intercept form, so we're solving for y. So minus 30x. So we have 4y equals minus 30x plus 10, 40. Why we switched to green, I don't know. Then we divide 4 from everything. So I get y equals, what's 30 divided by 4? Not very pretty, so leave it 30 over 4. What's 10, 40 divided by 4?
It's 260.
Thank you. Can I reduce this 30 over 4?
Yeah.
Be 15 over 2, right?
30 over 4.
So negative 15 over 2. That's just an easier fraction for me to deal with. Okay, so there's that equation. And then the other one was 8x equals 256. So get x by itself. What's 256 divided by 8?
It is 32.
Okay, so there's your two linear equations. Okay, when you have no y value, what kind of line is it? It's a vertical. It's on the x line, but it's a vertical line. And then we have our other one. So I'm going to re-enlarge this now that you have those two equations.
Wait, vertical is up.
Yep. So you see here they have our vertical line, x equals 32. And then our other one, our y-intercept was at 256. And then our slope was down 15 over 2. So you see it's graphed. This is where I don't like graphing because it would have been just so much faster to solve. Wait till I teach you substitution. You're going to love that one. That's the one you're going to do the most. All right, so they appear to cross where? We know they cross on the vertical line 32 and then the horizontal line at approximately 20.
Basically 20.
Wait, how did you graph?
Which one?
You go down 15 and right 2 right.
Yeah, so they started at 256, you went down 15 over 2.
Yeah.
This is difficult. This is why you want to just plug it in. Okay, so they plugged in 3220 to see if it fit. And it does. That is where they do intercept. Any questions?
Can you show us the way that you would do it?
Yep. I was about to, because that was ugly. Okay, everybody got that done?
Yeah.
All right.
There's only 5 questions.
6, I think. All right, you have these two equations written down because I'm going to ask you to tell them to me again.
Yes, I do.
Actually, I don't need that. All right. Let me stop mirroring my screen because I want more of the whiteboard. Okay. So we ended up with x equals 32, right?
Yes. And then y equals negative 15 over 2x plus 260.
Plus 260?
Yeah.
Okay, so when you're solving for x and y on this, when you get one variable by itself already, like this, just plug it in right here. So y equals negative 15 over 2 times 32 plus 260. Somebody do that. 15 over 2 times 32 is what?
It's negative 240.
Okay, negative 240
Yes.
plus 260.
It would be 20.
What did they get for y?
For
So why they got 20?
Oh, looky there. Missy's got it the same way. And 100 times faster than graphing.
So,
You just need to understand the graphing. Okay, so when you get to word problems like this, if you want to solve it this way, please do. Okay, do the simple graphing ones like we did on the first example, but on these ones, yeah, do the math. Math will always get you the right answer, whereas graphing is subjective sometimes. Does this make sense on how I did this?
yes.
Okay. Do you want me to show you one where, I'm sure it's going to do it in the next lesson, but I can show you one where we don't automatically get the x equals 32. Everybody have this? Can I erase this?
Yeah.
All right. Let me close this.
Oh my gosh, so much time. Yeah.
I'm just trying to find an example real quick. All right, here we go. Okay, so if you have this, and I'm sure this is our next lesson. Let me go see. Yeah, this is literally our next lesson, so this is a preview. So if you're trying to solve this system of linear equations without having to graph it,
yeah.
My favorite is substitution, which we're going to do Monday. You want to solve for one of the variables, so one of these. Which one would be the fastest to have on the equal sign by itself already? This guy, because he's already over here by himself, right? I just got to get rid of the 6. So then I have x equals negative 4 over 6 would just be negative 2/3. Over 10 over 6 would be 5 over 3.
Negative 2/3. And negative 10 over 6 would be negative.
Reduces to 5/3, right?
5. Yeah.
Yep.
Oh, wow.
Okay, now is that solved for a variable?
Not yet. Yeah.
Yeah, x is by itself, right?
Yeah.
So then this entire thing stands for x. So over here, I can do 2 and then open parentheses and write this entire thing. Minus 2/3 y minus 5/3 equals 18. We're not going to do this. I just want to give you a quick preview. Because numbers 1 through 6 that you have to do today, you don't have anything more as difficult as this.
Yeah.
So, but I did want to show you the mathematical way to solve it is so much faster. Because then I would just distribute and solve for y, and then I'd have my x and y value. Well, you'd have your y value, and you plug it back over here, and then you get your x value. So, we'll do that on Monday.
Okay.
But
Okay.
you have 6 problems, which you're probably already almost done with, knowing you guys.
Thank you, Sis.
Of course.